Simplifying radicals. If we are looking at the square root of x squared y to the sixth, how can we simplify? Well, first, for the purpose of these examples, we're going to assume that x is greater than 0 and y is greater than 0, so that we do not have a negative under our square root. So if we're looking at this, when you are simplifying a square root, what you need to think of is what does each piece mean? So I have x to the second, so that means x times x. I have y to the sixth, so that means y times itself 6 times. When we're looking at what does this mean, so the square root means that you are looking for groupings of 2. For every 2 inside, you can pull 1 out. So I see 2 x's right here, so that means 1 comes to the front. If we look at the y's, I see 2 y's, so 1 comes to the front, 2 y's, so 1 comes to the front, 2 y's, so 1 comes to the front. So the square root of x squared y to the sixth is going to look like x y to the third. Another way that you can do this is think about your division. So if we think about division, I have 2 right here. 2 divided by 2 is 1. 6 divided by 2 is 3. Let's try again. This time we have a cube root. X to the sixth, y to the third. So that would look like x times itself 6 times, and then y times itself 3 times, all under the cube root. It's a cube root, so this time we would look for groupings of 3. So for every 3, you can pull 1 out. For every 3, you can pull 1 out. For every 3, you can pull 1 out. So this would simplify to x squared y. Or look at your division. 6 divided by 3 is 2. 3 divided by 3 is 1. Let's look again. The fourth root of 16, x to the fourth, y to the eighth. So 16, we could rewrite that. We could make that 2 to the fourth. So let's look at our division directly this time. So 4 divided by 4 is 1, so that's going to give us 2. 4 divided by 4 is 1, so that's going to give us x. 8 divided by 4 is 2, so that's going to give us y squared. Let's look at one that doesn't work out perfectly. So maybe we have the square root of 28. Well, 28, we can break that down. 28 is 4 times 7. So that means we have the square root of 4 times 7. Well, the square root of 4, I can do that. The square root of 4 is 2. But the square root of 7 isn't a perfect square, so we're just going to leave that as 2 root 7. Same idea. Let's look at the cube root of 108. If you're not sure how 108 breaks down, just start with something and go from there. I like to start with a low number, and then I just work my way up. So 108, I know that's divisible by 2, so 2 times 54. Well, I don't know too much about 54, so let's keep going. 54, I know that's divisible by 2, so 2 and 27. I was hoping to get another 2 here because it's a cube root, and then I would have been able to pull a 2 out, but that's not going to work. So let's think about 27. Well, 27 is 3 to the third. So that's something that we can use a little bit of. So we could rewrite 108 as the cube root of 2 squared, 3 cubed. Well, 2 squared, that's not going to do me any good. I don't have enough to pull out. But 3 to the third, I can pull that out. So that's going to give me 3 cube root, 4 left over inside. Let's try again. I have 6 times the square root of y to the 12th. There's no number here, so it's an understood 2. 6 is already outside, so nothing to worry about there. 12 divided by 2 gives us 6, so y to the 6th. Let's look at the square root of x to the 5th, y to the 9th. There's nothing here, so it's an understood 2. 5 divided by 2, well, it goes in twice, but then there's the one left over. So 5 divided by 2 is going to look like x squared on the outside, but there's still an x left over. Y to the 9th, 9 divided by 2, well, if it were 8, 8 divided by 2 is 4. So 9 means that we would have 1 left over. So we have y to the 4th and 1 left over. So that's what it will look like when we simplify. Let's try one that's given in a fraction form. So let's say we have the square root of 8 over 50. Well, we can think of that as if it were the square root of 8 and the square root of 50. The square root of 8. Well, 8 isn't a perfect square. It's a perfect cube, but it's not a perfect square. But 8 is 2 times 4. So we could look at that as the square root of 2 times 4. And the square root of 4 is 2, so 2 root 2. 50, again, not a perfect square, but it is the square root of 50 is 2 times 25. So 2 times 25, that gives us 5 square root 2. Now something convenient here. I have square root of 2 on the top. I have square root of 2 on the bottom. So these are going to cancel. So square root of 2 over square root of 2, that's the same thing top to bottom. It cancels, which leaves us with just 2 over 5. Let's try again. Say we have the cube root of 64, a to the 5th, b to the 12th, all over 27, a to the 14, b to the 5th. Couple ways to go about this. You could split it and do the cube root of the top and then do the cube root of the bottom. You could simplify inside your cube root first and then look at what you have from there. Either way works just fine, it's just a preference. We are working with the simplifying radicals, so how about we keep our radicals so we can get a little bit more practice there. So that would look like the cube root of 64a to the 5th, b to the 12th, all over the cube root of 27, a to the 14, b to the 5th. So let's look at our pieces one at a time. So 64, well, that is 4 to the 3rd, so that's going to come out to be 4. A to the 5th, 5 over 3, that just gives us a with 2 left inside. So a to the 2nd left inside. B to the 12th, well, 12 divided by 3 is 4. So b to the 4. And then let's look at the bottom. 27, that is 3 to the 3rd. So the cube root of 27 is 3. A to the 14, 14 divided by 3. Well, that doesn't really work, but we could pull out 4, and then we would have 2 left over. B to the 5th, well, I have right now b to the 5th, I'm looking at a cube root, so I could pull out b to the 3rd one time, and then we would have 2 left over. There we go. So now we can do some simplifying. 4 over 3, can't really do too much there. A to the 1st right here, a to the 4th right here, so that is going to give me a to the 3rd left in the denominator when these simplify. Here I have b to the 4th, here I have b to the 1st. So simplifying those, that's going to leave us with b to the 3rd in the numerator. Here I have a cube root of a to the 2nd and a cube root of a to the 2nd, so those are going to cancel. But I'm still left with the cube root of b to the 2nd in the denominator. So there we go. Now if you're watching this video and you've already heard about rationalizing the denominator, that is something that you could do so that you do not have the cube root anymore. In the course of this curriculum, it doesn't come until later, so for now we're going to leave it, and we'll look at that in a future video.